For this question, find the exact value for this integral t cubed and then square root of t squared minus 1. We can try to check with formula first. So if this is our function, so we assume this is our giant function, where e is power to 1 over 2. If this one is giant function, we try to differentiate it, we get 2t, so we can't get the pattern where this is linear, this is cubic, means that this is not the question that we can solve by formula directly. So we have to use technique of integration. We can use our substitution method here. So let us substitute u as our function, which is t squared minus 1. When we differentiate u respect to t, because it is in terms of t, we get 2t. And then what do we need here is t cubed and dt. So we have to figure out what to substitute with this t cubed dt. So as we can see in our du dt here, we only can get du, then dt moving out is t times dt. So only we can get a t dt only. So we managed to substitute one t only. So we still have t square haven't substitute. So if t square, how do we get it? From this, to get t square substitute in terms of u, it can be u plus 1. So we can substitute every term of t in terms of u. Now we proceed for our limit. Where limit, this is our t value, we have to substitute it in terms of u value. When t equals to upper limit square root 2, u, the limit will be square root 2 square minus 1. So we figure out what is our u value here. For lower limit, when t equals to 1, so 1 square minus 1, we get 0. So finally, every part of this question, which is in terms of t, we change to u, we substitute into the new unknown, which is in terms of u. So when I rewrite it, for lower limit, it will be 0. For upper limit, it will be 1. So for t squared, is supposed in terms of u of plus 1. So for this function, it will be u power of 1 over 2. Then for this t dt, it will be multiplied with 1 over du. So from here, we can simplify our integral here, where constant we can factorize up. And then for this, we can expand, where this is u to the power of 3 over 2. This is u to the power of 1 over 2. Then we can start integrate. So this independent unknown here, we integrate by using power plus 1 over new power. So 5 over 2 straight away I put up. Again, power plus 1, 3 over 2 over new power. So we can substitute the limit now. So substitute 1 and substitute 0. So notice that when we substitute 0, everything becomes 0. So value out this answer, give in exact value. So give in fraction exact value, means it do one decimal here. So for these 6 marks, how we going to get these 6 marks when we changing everything in terms of u? Starting Assume the u correctly for the function t squared minus 1 and differentiate it. And then changing t squared, changing limits. Then write everything in terms of u correctly. So this is our basics here. Then you can start integrate to get the answer. So of course, we have to write out our upper limit minus lower limit.